Hello, this is David Martin on the Hybrid Cloud Gateway team, and this is our feature demo for Milestone 2 March 2023. So included in today's demo, we have a number of things building on what we delivered from Milestone 1. So the first thing was showing an integration between HCG and the workload clusters using a syncer component and the idea of cluster registration. That syncing component, that'll be important for the next thing we want to show, which is central gateway management in the HCG control plane. So I'll show a little bit more about that on the next slide when we talk about the architecture. We've introduced a managed zone API as well in the control plane, so tenants can have flexible DNS domain and subdomain management, and they can even do DNS delegation. I'll explain what that means during the demo. We'll show a quadrant rate limit policy being used with a HCG managed gateway as well. So our application running in the data plane will introduce a rate limit policy to that and see it kick in. And as we go through the demo, we'll start to show a clear distinction between the gateway admin persona and the application developer persona. So to start to define that split. So looking at the architecture, we have the control plane shown on the left hand side here, and we have the data plane with one or more workload clusters on the right hand side. In this demo, I'll have two workload clusters. Now also shown here, we have three personas, two of which we mentioned already. So on the left hand side, we have the gateway admin. So they're responsible for defining gateways and registering clusters, and also defining managed zones for a particular tenant. The gateways that they create, they'll be instances of a gateway class that HCG provides. It's a multi-cluster gateway class. Over on the bottom right here, we have the application developer. They're responsible for deploying their application, including the service and HTTP route. And we'll also add a rate limit policy to their application as well. Just above that then, we have the application user. So in the demo, we'll use curl to represent the application user. They'll be doing a DNS lookup for the host name of our HTTP route. That'll respond with the IP address or IP addresses of the gateways of the data plane clusters. So there'll be DNS load balancing taking place. And then traffic will flow down into the HTTP route and ultimately to the application. The rate limit policy, we'll see how that plays in as well. One other thing in the data plane cluster here, we have the data plane syncer component. So that's responsible for syncing down the gateways that the gateway admin has defined up in the control plane down into each data plane cluster. It will also sync down other things like TLS certificates. So TLS certificates, that's a feature of HCG where if it will go off to say, let's encrypt to get a signed certificate for your routes. So let's move on to the demo. And we may refer back to the architecture diagram when it makes sense to reinforce certain things. So for this demo, I'll have 4 terminals. To help reinforce the personas, what I'll try and do is keep actions of the gateway admin in the top left when they're interacting with the control plane. In the top right, we're going to use, say, Argo CD for pushing down the application to both clusters. Now, it doesn't have to be Argo CD. You could use anything you want to, as the application developer, to deploy your application resources. But in this case, I'll use Argo CD. Then in the bottom left and right, we have the 2 data plane clusters. So we'll run commands primarily as the application developer in either of those 2 clusters. However, first what we want to do is deploy that syncer component and get these two clusters registered back to the HCG control plane. So let's get that going there. So we can see the sync agent pod coming up on the first cluster. That's now ready. And we can see it coming up on the second cluster, and that's ready as well. So this sync agent uses credentials to talk back to the control plane cluster. Let's jump back to the architecture diagram. So as the data plane syncer talks back to the control plane cluster, it's limited in what it can see to just the tenant namespace here. So it will see any gateways that we create, and indeed any other resources that are kept in that tenant namespace. We can see there's a secret in these clusters as well, this control plane cluster secret. That represents the kube config for talking back to the control plane cluster. And indeed we'll see that on the second cluster as well. Now, the managed zone API, let's have a think about that. So we have a managed zone that's offered by default to gateway admins. And I've also created a managed zone ahead of time to show off some DNS delegation. So let's have a look at those here. So let's look at this one first. So this is the default managed zone, and we can see there's a domain name specified here, dm.dev.hpapps.net. So the gateway admin and any other gateway admin for other tenants of HCG, they can leverage this domain name for their applications. So they can have myapp.dm.dev.hpapps.net. They can have whatever they want, .dm.dev.hpapps.net. Now that might be fine up to a point, but a tenant may want to register their own domain and have HCG manage the host names and the certificates for that domain. So that's what I've done up here. I've created a managed zone in my tenant namespace for apps.davemartin.io. Now HCG uses Route 53 to manage zones DNS records. Now that doesn't mean that I'm limited to Route 53 for my domain. In fact, I've registered davemartin.io with Cloudflare, but what I can do is delegate the DNS over to HCG so that it can manage it in Route 53. And the way we do that is we can see some name server entries down here in the output of the managed zone. So there's 4 of them. What I need to do is go to my DNS provider, Cloudflare, and add NS entries for the 4 of these. Now, I've already gone and done this ahead of time to save us a little bit of time, but we can see that here there's 4 NS entries for apps. So apps.davemartin.io. So now whenever someone looks up apps.davemartin.io or anything.apps.davemartin.io, it will actually be delegated to a zone in Route 53 that's managed by HCG. And if we jump over to Route 53 to the HCG account, we can actually see that that zone has been set up, and we have a couple of default entries here. As we go through the demo, we'll see some A records show up here for our app. Okay, so next let's create a gateway. So as the gateway admin, I want to define some listeners. I want to create my gateway. I want that to get pushed down and synced to the data plane clusters. So I'm going to create a fairly simple gateway. It'll have one listener, as we see here, port 443, so it's HTTPS, and I've decided this is what my host name is going to be. So as the gateway admin, I've either decided or I've talked with my application developer, and we come up with this is the host name we're going to use. So I want that listener to be put in place on both data plane clusters. So let's create that. So the gateway has been created. Let's have a look at the status of that in the control plane. We can see, first of all, it's accepted and it's handled by HCG. That's what this means. We can see that right now it's not programmed, or rather status unknown. It's pending. It's waiting for the controller. All that means is there needs to be at least one HTTP route attached to the gateway before it can successfully say things are programmed. However, what we can see is that what HCG has done, it's created a certificate. It's gone off to a certificate provider such as Let's Encrypt, and it's created a certificate for our host name. It's gone and done that ahead of time, so you can see that here. Now, here's where it gets interesting. If we start to look at the gateway in the data plane clusters, now that the syncer has taken that and synced it down to the clusters, we can see, well, first of all, it does exist. And second of all, if we scroll up to the listener section, here's our listener. And we can see that there's a little transformation having taken place here. A TLS section has been added and it has a reference to this certificate. We saw that certificate up here. We can see it now being referenced down here in this namespace. So the syncer has also taken its secret from the control plane and it has synced it down to the right namespace in our data plane cluster. And if we look at cluster 2, we'll see it's done the same thing as well. So the listener block, here's our listener block, and we can see the TLS section with the certificate ref. We can also see the secret exists here in cluster 2. So just to reiterate what we've done so far, back in the architecture diagram, our gateway admin has defined the gateway, which is an instance of this multi-cluster gateway class that HED provides. The HED data plane syncer in both data plane clusters has synced that down, and it's transformed it to include the certificate references. So there's an instance of an Istio gateway running on both clusters now. So next, let's deploy our application to both clusters using Argo CD. So I have an application set that I'll apply to Argo CD up here, and we can open up the Argo CD UI and have a look at that, what's going on. So we have two applications, one for each cluster, and if we jump into one of them, we can see there's a service, there's a deployment, and there's a HTTP route. If we have a look at that HTTP route, we can see the host name that we're trying to use, and it's referencing our gateway. If we scroll down a little further to the status though, we can see that it hasn't been accepted yet. There's an issue, not allowed by listeners. And we have some more information in the message here. So host names matched parent host name, but namespace MCTC demo is not allowed by the parent. So that's telling us, for those who are familiar with gateway listener setup, the gateway is not allowing HTTP routes from this namespace. So let's fix that. So I have a little command here to patch the gateway. Let's have a look at it. So we're going to add something here. We're going to add it under our listener, under the allowed routes, and we're going to say namespaces all. In other words, we want to allow HTTP routes from all namespaces in our data plane clusters. So if we jump back to our HTTP route in Argo CD, we can see here already it now says that it is accepted and the route was valid. So in theory, we should now be able to hit our HTTP route. We should be able to hit our host and get a response from our application in either of the data plane clusters. But before we do that, there's one other piece I want to just highlight, and that is the DNS record. When did that get set up? What does that look like? So if we have a look for DNS record resources in our tenant namespace back in the control plane, we'll see that one exists for our app. Have a look at the YAML of that. We'll see a little bit more information about endpoints. We have 2 endpoints, and there's 2 different IP addresses showing up here. So those are the IP addresses of the 2 gateways, one in either data plane cluster. And we can see that HEG has taken this information and it's gone off to Route 53 and it's added some records there. Let's give this a refresh. So here's our 2 records. We have an equal weight on both. And for the purpose of the demo here, I'll set the TTL quite low, just to show the DNS load balancing taking place when we start to curl the app. Okay, so let's curl the application. Let's see it all happening. We'll clean things up a bit here. So let's clear these, and let's tail some logs here. So we're tailing the logs of our application in cluster 1 and cluster 2. So whenever we hit an endpoint in either application, we'll see a log line being output. I have a little while loop going on up here. So we will be hitting our application endpoint here once every 2 seconds, and we'll see responses below, as well as the response code coming up here. So let's kick that off. I'll leave that go for a sec. So let's just jump back to the architecture diagram just to show where we are. So we're acting as the application user here. There's a DNS request going off to Route 53 for m2demo.apps.davemartin.io. It's responding with one of 2 IP addresses, depending on the weighting and the response. It'll either hit the traffic will either hit the gateway in data plane cluster 1 or data plane cluster 2 and go on to the relevant application. So we should see logs roughly even between the 2 of them, and we should see 200 responses as well. Because the TTL is 5 seconds, we'll probably see it in groups of requests, say 2 to 3 hitting one of them, and then it might swap over to the other one depending on DNS caching. So far it seems to be just hitting the first cluster, so I guess DNS is behaving a little bit oddly there. Not to worry. Let's try this again, and we can pass in an override to curl. Let's tell it a cache timeout of 5 seconds, and we'll see if it starts to hit the second cluster as well. While it's running, one other thing to kind of highlight. So why define your gateway up here in the control plane? Well, one good reason here is that we can add all of this DNS and TLS functionality. So we're taking away that pain from having to do that with each individual cluster, bring that up to a central control plane. And now if we jump back to our application user, we can see that there's traffic hitting both clusters. So let's cancel out that. Let's clear things up. And what we're going to do now is add the rate limit policy and see what happens there. So this is using the quadrant operator, and we'll use a component called limitador under the hood. So we'll introduce the rate limit policy down here as the application developer. To do that, we're going to make a small update to our application set in Argo CD. And I'll show that in one sec. Let's just apply it first. We'll go back to the Argo UI and give it a refresh. And we can see that there's a new resource down here, rate limit policy. So this has already been synced down by Argo to both clusters. If I have a look at the status here, we can see that the HP route is rate limited. So if I start to curl my app again, actually let's kick that off. We'll get some requests going and then we'll talk about that. What we expect to see is some 200 responses, and then as rate limiting kicks in, we expect to see a response of 429. So let's leave that off for a little while, and then eventually we'll see that kick in. Now, just another bit about the value of defining your gateway centrally. So as we introduce new, say, APIs, so if we jump back to our architecture diagram. So we had the managed zone API, but if we bring in, say, some policy-based APIs. So what if we were to bring that rate limit policy up to the control plane and have some idea of multi-cluster rate limiting, so different rate limiting strategies? Or what if, as the gateway admin, you were to define an auth policy, a kind of a default across all applications in data plane clusters, auth policy, or some health check policy. So each application needs to satisfy some particular health check endpoint, for example, before it is accepted by HEG and added to DNS. So as we introduce new kind of policy-based APIs, that start to show the value of defining that gateway centrally, because you can associate those policies with the gateway itself. So back in as our application user, we can see a few things happening here. Well, first of all, our responses as we loop through things, we see 200s and then 429s. That's showing that rate limiting is kicking in from limitador provided by the quadrant operator. And we can see that requests are hitting both clusters again. Now, depending on the DNS response, it may hit one more than the other, as we're seeing. Right now, it's hitting this cluster. So there's DNS load balancing taking place. And in future, that's another angle as well, actually, where we can provide value with HCG. We could do geo-based routing. So depending on where you are in the world, it can hit one or the other instance of the application. So that's it for the demo. I think we've shown all the pieces here. If you do have any feedback or questions about this, you can reach us on Slack here. You can also reach us on this mailing list, and the HEG control plane component. You can find that on GitHub at this address here. Thanks.